So, believe it or not, I've known Peter for almost 40 years. I first met him at Stanford when he was an undergrad student in mechanical engineering, and he was working on a project which he'll say something about, right? Handbike? Yeah, okay. And we kept in touch for all these years. We're in the same professional society, and Peter's been here for how many years in a row now? Maybe at least
a bunch.
10 so. So Peter is a rehab engineer who sustained a spinal cord injury in 1975 in a climbing accident at the Air Force Academy. He continued his education at Stanford, where he began applying engineering and design principles to overcome his daily living hurdles, as well as those faced by people with disabilities. And in 1981, he founded Beneficial Designs, an engineering design firm dedicated in designing, developing, and testing assistive technologies. His company's accomplishments include developing the first chairlift-compatible monoski with a shock absorber, and he worked to establish wheelchair testing standards, improving seating systems for wheelchairs, and creating a system to assess trails that will improve access to outdoor trails for people of all abilities, and we'll be talking about all that. So Peter is the founder and director of research and development at Beneficial Designs, which is in Minden, Nevada, just south of Carson City. And he spends most of his time traveling throughout the world, including Palo Alto, attending meetings and presenting his work. He's also an avid pilot. He has an adapted plane that he flies, and an avid monoskier. So let's welcome Peter Axelson.
Thank you, everyone. It's great to be here today. I'm going to go through a lot of visual images. Is there anyone that can't see them very well, or somewhere in one of the screens? Okay, awesome. I'll make sure my clicker's working. Putting it over my shoulder. Dave already told you how I got hurt. I was hurt in a rock climbing accident during training at the Air Force Academy, Colorado Springs. And so I got kind of redirected into a different field of engineering. I was studying aerospace engineering, doing wind tunnel experiments, and I found myself with a spinal cord injury, paralyzed from the waist down, still trying to figure out how to do things that I wanted to try to do, because there wasn't a lot of adaptive recreation equipment out there, and recreation was an important part of my life, and it's an important part of everyone's life. I think your recreation and leisure time is important to you. And so I started designing equipment, and I'll be showing and sharing some of those ideas with you. And so I look forward to zipping through these slides with you. I will be I finished all my meetings today, so I have some time tomorrow morning. So if anybody needs help meeting on their project, I think there's one group that I'm going to try to meet with for sure in the morning. So if anyone else wants to try to meet with us in the morning, can probably figure that out. So I want to just tell you that when I started Beneficial Designs, I had no intent of starting a company, but I designed something that I couldn't figure out how to make available for other people. Nobody would make the thing that I had designed, and so I started the company just to make this thing available for people to try it out. And next thing I knew, I was manufacturing adaptive ski equipment, and Beneficial Design sort of unfolded from there on out. And so we're a company that we work through universal design concepts to doing all various research projects, design projects, and educational work. And we believe that all people should have access to physical, intellectual, spiritual aspects of life. And so we work mostly with mobility impairment, but our company now is working more with all kinds of impairments, all kinds of disabilities in the projects that we do. So I'm going to take you on a tour through them. And we do most of our solutions. Some of them are software, some of them are products, some of them are hardware, some of them are processes, some of them are assessment processes, and some of them are standards, so that we can make things accessible by creating standards for stuff. So I'll take you through all of that. I'm the leader of the company. I'm just going to show you the kinds of people that work with us. Shauna has a mobility impairment as our research director. Bill's our IT person. So we wanted you to see the different kinds of people that work with our company. Stephanie has her PhD in education. She is kind of helps write proposals and projects. We have a bookkeeper, office assistant. We have a lot of administrative assistants. This one's over in China right now studying for the year. She'll be coming back in the summer. This is my daughter 5 years ago, and she's here today. She started out shredding paper, and now she's excited this summer to learn how to do powder coating. So she's working in the shop. Her favorite class is welding, and she's in the high school, so she's in the back of the room here. Embarrass her. And we have some of her other friends, office people. We have a bookkeeper. We have a machinist. I'll show you some of our equipment. We have a guy that runs our wheelchair test lab. We test wheelchairs, powered and manual wheelchairs. We have people that go out and teach trail assessment work and do sidewalk assessments and trail assessments all over the world. We have a GIS student that's working with us. We have a software student that's learning programming that's working with us. We have a graphic artist who worked with us from Dubai for 6 years, and now he's come back from Dubai, and so he's in our office again with us. We have a mom that's her son went off to school. She's come back. She's a GIS person doing our geographic information systems for our maps that we do. We have an electrical engineer that lives in Montana and Germany that does our circuit board designs. We have a retired math teacher that does our sidewalk assessment work. We have an architectural draftsman that's an expert in the sidewalk assessment stuff. We have a rancher that actually helps me do all the amusement park accessibility work. And so when you walk into our facility, you see that we have all the same sorts of shop equipment that you're probably maybe learning how to use: drill press, bandsaw, bead blaster, powder coating oven, mill, machine, lathe, a little CNC that we can use, 4-axis. And we're inside of an airplane hangar is where our company is. And so once in a while there's an airplane in there. That's the plane that I fly down here, and sometimes it's torn apart right now, so I wasn't able to fly down here. But a lot of our test equipment is around the perimeter of this hangar, and our machine shop is in the hangar. We have precision equipment that has to be calibrated quite frequently for calibrating our rotational penetrometers. I'll tell you about those. Our powder coating. This is our design area where we all have our desks and work in that area. We have equipment for testing wheelchairs. This is a static strength tester pushing down on the arm support of a wheelchair. And it's trying to see if the arm support's going to hold the weight when somebody does a pressure relief or transfer in the wheelchair. We have things that swing out big heavy metal objects that weigh 55 pounds and smack them into the foot supports of the wheelchair and the front casters. We have drum machines that we've built, and these drum machines, one of them is run by a motor, drives the drums around with slats, and then the wheelchair is loaded up with a test dummy inside so that it gets jostled around. It runs about 200,000 cycles to make sure it's going to be durable for at least a 5-year period. We have another version of that drum tester that's the powered wheelchair actually drives the middle drum. Most powered wheelchairs have 6 wheels now, front wheels, front casters, rear casters, and powered wheels in the middle. We call them spider chairs because they can kind of climb over things better. So the chair actually drives the drum tester and provides the power. We supplement the power a little bit. And then we have a drop tester. This is the most brutal test. It picks up the chair a couple of inches and drops it just kaboom down to the ground with that 300 or 400 pounds of weight inside the chair. And it does that about 7,000 times. So before we do the testing, we calibrate the test dummy by tipping it forward to see where its balance point is, and then we tip it back, and then we know we can make sure it's calibrated right. We test everything from scooters, power chairs. This is a track chair for somebody to go out hunting so they can like sight in on the game and climb over logs and trees and streams and all that kind of stuff. So we got a standing test dummy in that chair. Powered wheelchairs are really super adjustable. Maybe you've been over to the VA and seen some of those chairs. This one has a tilt in space. You can see it's all the way tilted back. So we want to make sure no matter what configuration that chair is put into, that it's not going to fall over and cause somebody to get injured or hurt sitting in that chair. So we test it forward stability, rearward stability, lateral stability. And then we have a big giant ramp. Do you see the airplane in the background there? That's a 30-foot, it was 20 feet in this picture. We just lengthened it to 30 feet long. So we've got to be able to get those wheelchairs up to full speed, which is sometimes about 8 to 10 miles an hour. And then we throw the brakes on to try to make sure it's not going to fall over forward or backward or sideways. And so that's our goal, is to try to destroy the wheelchairs. And the guys that work for me get really excited when things fail. The manufacturer is not very excited, but the guys that work for me love to see things fail because it's exciting for them, and the weights go crashing all over the place. And there it is, crashed down to the ground, tipped over backwards, going off of a curb. So that's sort of our facility and what we do mostly at our facility. I'm going to talk to you now about designing consumer products. And initially, I spent my career designing a lot of different consumer products. We do product development. We also assess other products, and we do that by looking at ways to create adaptive equipment for people with disabilities. So if it's a personal technology, like the glasses you wear, that's a personal technology, right? The clothing you're wearing is a personal technology. My wheelchair is a personal technology. It's something I need to do everything I do. I have to have it with me. But a lot of what needs to be designed are technologies that are specific to certain activities. Like if I want to ski, I need a special piece of equipment for that. If I want to go hiking, I need a special piece of equipment for that. And so beyond sort of adaptive products, we can sort of make all products more usable. So like the washing machine might have the controls in the front, and it might be raised, so it's easier for everyone to use, right? So there's things you can do to make all products more universally accessible. So your experience in this assistive technology class is going to make you a better designer all around, because you'll be thinking about the disabilities and people that you work with that will maybe use a car if you're designing a car or something. So mainstream products always have more room to make them more universally accessible for different people. The other thing to think about on your project teams, I know you might be working with one specific person with a disability or a group of people with disabilities. Think about how that person wants to possibly be able to be physically more active, or they want to perhaps express themselves intellectually or spiritually. So there needs to be a balance. So each one of you has your own balance between what you like to do physically, intellectually, and spiritually. And if you have a disability as a result of an accident, you're going to want to reestablish that balance close to what you were doing. If you're physically active, you're going to want to figure out how to continue to be physically active. So this is a few years ago, embarrassing my daughter again here. She likes to go on vacations, and we like to do fun things like, Dad, let's go rafting. Okay, let's figure out how to do that in a wheelchair. Piggyback, down to the river. Not just a life jacket up here, but a life jacket on the legs, because we don't want the legs to go get tangled under the water. So you're always thinking about things that you have to take care of, or fly fishing, which is another thing I like to do. This is a nice universally designed platform on the Carson River up near where I live in close to the Sierra Nevada mountains. And just being able to get out there. Benches need to have places to sit next to them. Dad, let's go ziplining. Okay, how do we do that? So we figured out a way to put a harness not just on my chest, but also on the legs to keep them up. So when you go sliding into the next tree, you don't hit the platform that you're trying to land on, right? So we hooked me up with a couple sets of pulleys, and off we went, sliding down the mountain. So it's all about like figuring out how to adapt things quickly so you can go out and enjoy life. The other dimension I want you to think about is like some of you are very, very independent people, I bet. But some of you are maybe more, you like to always do something with somebody else. You're more interdependent, or sometimes people like to do things dependent on one another. And so that's sort of a tolerance level that everybody has. How dependent do you want to be on somebody else for certain things versus being independent on certain things? And so this fellow, he's in my hiking chair there. We ran into boulders. Well, he had to get help getting through the boulders. The chair can climb over a lot of things, but it doesn't climb over boulders. This guy wanted to skydive, and he's a high-level tetraplegic, and he's got a scuba regulator that he's breathing on because his ventilator is on his powered wheelchair down on the ground. And so he's doing a tandem jump with this instructor skydiver person so that he can do that. I wanted to learn how to keep flying again, and so I started flying ultralights. This is the ultralight that I was flying in. And now we're going to move into talking about some of these different kinds of activities, the personal, the activity-specific, and the environmental. First, on the activity-specific, my student project here at Stanford was to design a sit ski so I could ski again. I didn't think I would want to go out in the snow again because I didn't like thinking about how I used to do things and how I couldn't do them quite the way I used to do them. But I got tricked and said, would you test this little sled from Norway? And I got in it, and it was kind of like going down the hill on a lunch tray. It went as fast sideways as it went forward. And so I thought, I can design something that'll work better than this. So the sit ski was one of my student projects at Stanford. And that evolved into eventually the monoski. And this monoski has a shock absorber in it to absorb the bumps like you would with your knees, and little skis with ski tips or outriggers, Canadian crutches with ski tips on them, which they call outriggers when you're skiing. So that gave me an opportunity to start skiing again, which gave me an opportunity to start racing again, and I raced on the U.S. Disabled Ski Team for 8 years, so that was a lot of fun. Downhill and Super G were my favorite events. Now there's also a thing called a bi-ski on the right in that image there. Bi-ski has two skis underneath, so when you lean or tilt the ski, those skis tilt and then it turns. So for people with even less balance and maneuverability, they can sit in the bi-ski. They all have to fit on the chairlift, so you can get up the mountain and get off the chairlift when you get to the top. And I don't have any back muscles when I lean forward. About there, I just fall over. And so for monoskiing, I wear this harness on my chest, and then there's a fiberglass spring rod in the back there. It's kind of like a fishing pole. In fact, it actually has a fishing rod ferrule on it that plugs into the back of my seat. And when I flex forward, it bends that fiberglass spring rod no matter which direction I bend, and then it helps spring me back up into position. So I use my stomach muscles to flex myself forward and let the spring help me sit back up. So that's how I ski. And then I started putting bungee cords in lots of my designs. So this is a cross-country ski, and on the left side you see me reaching forward, and you can see the whole frame is kind of tilted forward, so I get a better reach with my poles. And then on the right side you see the frame is kind of tilted back because this bungee cords kind of spring back, and it's sort of almost like a kick and glide. If any of you have cross-country skied, it has sort of a kick and glide motion, and it actually is faster. So this is my backcountry ski I designed. So this is kind of a monoski with two little cross-country skis on the side. So when there's a cross slope, and you're familiar with the tracks in the Olympics, they ski in those the two tracks. Well, those are pretty level, but if you're in the backcountry, you might be on a cross slope, and then you just want to put the uphill ski down a little so you don't fall over. So that's what this ski is designed for, is the backcountry ski. So I wanted my everyday wheelchair to be more comfortable, so this is a thing called the Pax Back. Pax is my nickname. That gives support through the upholstery of the wheelchair to make it more comfortable. It's sort of an upper lumbar, lower lumbar, upper sacral seat support, and this is the same basic design that the Arion, you know, the mesh seat backs with the support on them is based on this concept. I used to play the piano, got a little frustrated I couldn't work the pedal, so this is Peter's pneumatic piano pedal pusher. It's got a real simple beach bellows pump on the floor that pushes the pedal up, and then I wear a blood pressure cuff, you know, like they put on your arm to take your blood pressure. I wrap it around my stomach, and then I pump that up, and then when I tighten my stomach muscles, it pushes the piano pedal to work the sostinato on the pedal. Hand controls. They make hand controls for cars with automatic transmissions. You usually always push the brake and twist for throttle or move some other direction for throttle. But I wanted to try to drive a 5-speed. So I designed a control that had the push for brake, rotate for clutch, and twist for throttle. So on a hill, you can push the clutch in, push the brake on, apply the throttle, slip the clutch, and let off the brake with one hand, which is, turns out it's easier than for like 2 feet and a hand on the hand, you know, it's all in one. Works really well. So then I don't know if some of you seen, there used to be kind of this kneeling seating thing. Some people like to sit on balls, and it's called a balance seating, and so I wanted to try that out. So I built a balance chair that I could sit in and put pressure on my knees and sit in a more upright position. So I thought I'd design a wheelchair to sit that way. So on the left side there, you can see it in its sort of most forward position that I would use at a desk. And then in its rearmost position, my knees actually come level, and I'm riding on just the back wheel and the main wheels for driving around. This is my hiking shoes. So some people, you know, you have a different pair of shoes you put on when you go for a hike. You don't wear your tennis shoes or whatever. So this is basically my hiking shoes. So if I want to go on a hike somewhere, I have a whole other piece of equipment that I take with me, not just a different pair of shoes. So you carry a big van, maybe, keep all your adaptive equipment in so you can carry the stuff that you need to go hiking. This chair has 4-wheel disc brakes, so I can clamp the brakes on and I can go down a flight of stairs in control in this chair, and it'll go like about 50 miles an hour if you want to, but so it's a lot of fun. Hand bike was one of the projects I worked with Dave. Doug Schwant's not here today, but maybe some of you guys have met him. But there was another Stanford student that worked on this project, and I had the concept and they worked on it as their project. It has little outrigger wheels. Once you get going, you can pull those up. It balances on 2 wheels, just like a regular bike. And his brother actually manufactured those bikes, and he did a tandem version where the hand cranker is in the front and the other rider's in the back. I've done a lot of custom contoured seating for things because people with spinal cord injury have no sensation, and so you always have to sit on a pressure relief cushion. And so this pressure relief cushion is actually contoured to match my bottom, and it says airplane pilot seat. So that's the seat cushion that I use in the aircraft that I fly. And I want to talk about this pressure relieving thing for a minute with you guys, because relieving that pressure and having a contoured seat is really, really important for almost every project involving someone that doesn't have sensation. And so we actually built the gel butt, we call it. We took a plastic skeleton and molded it into a gel bottom so that we could test seat cushions. And so we put it in a sort of a drill press kind of thing and press the gel butt down into the cushion. We can use a pressure map to measure the forces. So as you can imagine, the blue is friendly forces, greens are good. As it moves on up toward the red would be bad pressures, right? So these pressure maps are used to measure the difference between different types of cushions. Here's a whole bunch of different types of cushions. The one on the right is the air-filled cushion, really nice pressures, and the one on the left is more of a foam cushion. So you can see you get different amounts of pressure relief depending on the cushion that you're using. So we also wanted to look at people that have skeletal deformities. Maybe they have a pelvic obliquity where they sit to the side or their pelvis tilts back. And so we made an adjustable skeleton so we can see what a pressure looks like when it's symmetrical. And then if we tilt the pelvis 10 degrees, look what happens. All this red over on the sitting bones on one side. And so if we tilt the pelvis back, we get a lot of bad sitting pressures in the back. So we can imitate those different pressures. Other people have problems with spasticity in their wheelchair where they spasm and they extend into their chair, their pelvis thrusts forward. And so we wanted a way to try to experiment with not just the angle that we hold the person in the chair, but do it maybe with an elastic restraint to sort of allow them to spasm and move, but to bring them back into a good posture in the chair. So we invented this thing called the hip grip. This is one of my employees' concepts, actually. And it holds the pelvis, but it lets it spastically sort of move and come back into place. So we went through the prototyping, we went through fittings with different people, and there's a dance group in San Francisco and Berkeley called Axis that the dancer uses the hip grip to be able to make moves in her chair to come back into that upright position. And we always test everything, so we put this one on a machine and cycled it about 1 million times to make sure the elastics and everything would work. We also look at functional ways to measure how well something is working. So if somebody's going to try to reach, we might see how far they can functionally reach before I lose my balance with both hands. Or we might try to see how far can I functionally reach to the side before I lose my balance. Or different things that we test. So I'll show you some others ways we test it in a little bit here. These are the FlexRim wheels that I designed. The hand rims on the wheelchair can be very difficult to grab a hold of to push because they're slippery. They have to be slippery so that when you brake going downhill, they're sliding through your hand, you don't burn your hands. So we connected the hand rim to the wheel with a layer of urethane rubber so that when I push my hand on the chair, I don't have to grip anymore. All I do is push my hand on the urethane rubber to push the chair. So you can see how my hand fits into that rubber there to push the chair. And so we found that it gave a really good frictional improvement, and it increases it by more than twice. It also absorbs the impact, so my hand rims are sort of like wearing tennis shoes compared to wearing street shoes. So when I'm pushing on those hand rims, the impact is not coming up through the bones of my shoulder to my shoulder, so it absorbs that impact. We did repetitive load testing to see how long that would hold the load, and after 444,000 cycles we broke it, so we were pretty satisfied that we were getting a good life cycle out of that product. So we designed some instrumented wheels so that we could test these hand rims, and we set up a wheelchair biomechanics lab just like you would have for people, but we put it on a treadmill, an adjustable angle treadmill, and we put the subject on there, and we have a way to measure their expired gases, to measure how much oxygen they're actually using, we monitored their heart rate, we could monitor their grip with the EMG electrodes on their hand. We could do motion capture. We put markers on their body so we could see the stick figure on the computer to see how they're moving their arms and how far they're pushing, and we could measure the torque that they were applying to the hand rim in 6 degree and all 3 axes. So that was what we did and wrote a bunch of papers on to back up the research for designing the FlexRim. Spinergy is the wheel manufacturer that makes these wheels available for wheelchair users. We also designed a grip rim, which is a rubber sleeve that goes over the hand rim that you can squeeze to push. So if somebody doesn't have good hand function, they could just push against that grip to be able to apply force pushing or to do braking. A lot of people like to get out on the water because when you're on the water, everything's accessible. It's all level. Funny thing about water, it's usually pretty level, except in bad storms, which you don't want to be out in a canoe anyway. So we worked on adaptive canoe seating, and the molded seat on the left is the seat that's molded for me, and the seat on the right is the one that we designed through our research project. And there's a company that manufactures that seat called Chosen Valley Canoe Accessories, and they make this available for all sorts of water sports programs and adaptive sports programs for canoes and kayaks, because water sports is a good way to get people with disabilities out on the water, because the water is very accessible if you've got the right seating in your canoe. When we did the research for this project, I'm hooked up to the VO2 meter, and I'm paddling on a rowing ergometer with the Concept 2 that's been converted. And so we're measuring all the metabolics of the person breathing. We're doing lateral tip tests to see how far they can tip and still maintain their balance. And then we do a wet exit procedure to make sure they can still get out of this adaptive seating to make sure it's safe. So I hope I'm giving you some ideas on how to test your things that you're working on in your own projects. Another student project was this wave ski. There was a guy that was hurt surfing. He wanted to be able to continue surfing, so designed a way that he could strap himself in and have one cord he could pull to release all the Velcro and get off the ski. So the next thing I'm going to talk about are not design-specific things, but for specific activities, but making the environment accessible. So for water sports, you have to be able to get down to the boat launch or the beach, and so we've developed a rating system giving the grades and cross-ups and all the details about the access route on the water and on the beach. For trails, we use very simple tools, a smart level, chronometer, compass, roller wheel, and we systematically measure the grade, the cross-slope, the tread width, the surface, and the length of the trail. And we train people how to do this. We've trained over 1,300 people how to do this trail assessment process. And then we created instrumented equipment, so we have like a jogging stroller, gun cart looking thing that has a sensor box on it, and it can measure the grade and the cross slope, and there's a laptop on there and taking GPS and camera images. And you roll that down the trail, and we systematically measure all the conditions on the trail. We have a roller wheel version also, and we have a version that straps onto a wheelchair so that anybody can do it. So then there's a software interface that works out in the bright sun with real high contrast viewing screen. And then we have another version that's just a real simple roller wheel with a couple little smart levels on it, so that you can, that's sort of our lowest cost version of doing that. So what we create is these trail access information labels. And the trail access information labels have information like about what the trail name is, who the user groups are that are allowed. It'll have the typical and maximum grades, so you get an idea of how steep the conditions are or how cross-slopey the trail is, what the surface conditions are, and then what obstructions might be on that trail. So we create that signage on a vertical signpost, and those go out on the trails. A lot of folks put the flags on them so they don't get shot as much. It's a problem out in the rural West. People like to shoot signs, so we put the flags on them. And then we make panel maps that are like a 2 by 3 foot sort of panel. And this is up at Tahoe Meadows at Lake Tahoe, and we color code the trail, and then you can look up the data about the trail on the panel map to see which trail has the conditions that you want. So we've been doing this for parks all over the United States, and some of them want topo lines to show, some of them want a map view to show, but everybody wants an app. So we created an app last spring that we just finished. It allows you to measure and assess all of these things listed here that have to meet accessibility requirements: the picnic table, the grill, the rinsing shower, the water pump, all those things. So even like a picnic table, there has to be a clear space around it. You put in all the basic information, you make basic measurements, guides you through making all the measurements on the table, the height of the table, the clear space under the table. We even created a clear space gauge that shows whether or not the wheelchair will be able to get underneath the table. We look at camping grills, water pumps. We'll make sure they can be operated without fine finger control, so you can we'll measure the force to actuate the pump. So all these things, we created the assessment process for all these things, and now we're going to send thousands of people out, hopefully, to go do all these assessments to figure out what's working and what isn't. I got this idea from the reset. Do they have the room reset signs? I put the room back the way it was when you finish your design exercise. So I borrowed that from you guys to put on our signs for the campsites, because lots of people like to move the picnic table. And so to make the campground accessible again, you have to put the picnic table back where it belongs to make it accessible again. So we've got the reset symbol for that. This is a campsite showing what's accessible there. It's got a tent pad and the sides and the table. So all of these features meet the access requirements of that particular campsite. We've also created a website called trailexplorer.org, and you can go in there and put your state and put in like what's the maximum tread width you need or run the maximum grade, and you can find trails that meet your requirements. So after we worked on trails, we created an assessment process for sidewalks. There's a lot more sidewalks than there are trails, and so we wrote a guidebook for federal highways on designing sidewalks and trails for access. So there are design guidelines now. They're part of the Architectural Barriers Act. So it's actually the law when a new trail is built. It has to meet these guidelines unless there's a real reason that the site can't allow that to occur. And so they're kind of consistent with existing guidelines. 30% grade can go for up to a couple hundred feet. Steeper grades for shorter distances. And certain cross slopes, a lot steeper allowed on a trail than on a sidewalk, and then it has to be at least 36 inches wide. Another place people like to get to are playgrounds. So if you have a child that has a disability in a wheelchair, or a parent that has a disability trying to be out there with their children, we have a way to measure the surface for firmness and stability. The surface has to be soft enough that if a child falls off the highest equipment, you don't get a head injury, but it has to be firm and stable as well. So we test the playground surfaces. We put them in a test bed in our hangar. We have an instrumented wheel, so we push across that surface and we can calculate the work to cross a 2-meter distance on the surface, and we make sure it takes less work than a standard ramp, and then we know it's an accessible surface. We also have this portable device that we can take out in the field. It has a precision spring in it, so you set it on the surface, you stand on it, you release the precision spring, and the caliper reads the penetration into the surface, and then you rotate the indenter, and if it's an unstable surface, it digs in farther, and that's how we get the stability reading for the surface. So here's a typical trail that was very unstable. This is along the Tahoe Rim Trail up at Lake Tahoe. Real sandy kind of material, and they're not allowed to put any non-native material up at Lake Tahoe, so we scraped out this material that was there, and we put in this plastic structure that had a geotextile fabric under it. We fill it back in with the same soil that was there, and then you can't even see it when it's done, but it's now a firm and stable surface. So on the left you can see the penetrations. You can see the firmness was fine before and after, but the penetration, you can see the stability was almost over 3/4 of an inch, and after it was stabilized, it's like 0.3, 0.4 inches. So that made the surface firm and stable. So for measuring the sidewalks, we started out with the smart level on our hands and knees, and like, wow, this is back-breaking work. And to measure a tripping hazard, you need to take a profile gauge and then trace that onto a piece of paper and measure it. That's very time-consuming. So we created the sidewalk assessment process. So we created this really rigid cart that we could roll down the sidewalk, and we have a wireless wheel that we designed that you could roll out the distances. We have a height measurement device. You could just look at a spring plunger in it, step it on the height to measure the nearest millimeter. We created software for it. And so the assessor just goes out there. The right side is what you see on the screen. It shows you put the cart here on the bottom of the curb ramp. So the operator puts it on the curb ramp, hits the enter button, it pulls in the grade and the cross slope and all the information. It says now put the cart here, and now put the cart here, and now put the cart here. So there's each part of the sidewalk curb ramp has to meet guidelines. There's like about 30 things that you measure on a curb ramp to verify that it meets the access guidelines. Once we get that data, we can put it into a GIS map. So in the GIS map, like for tread width, for example, everything that's green there meets the tread, but everything that's red doesn't meet the tread because it doesn't have that sidewalk width that's required. Or here's the cross slope. You can see most of this is all yellow or red, meaning it has an excessive cross slope. Or these are tripping hazards. So you can see the cautions and the reds. Those are all the places that we identified tripping hazards where they need to come in and grind the lip between the concrete panels to prevent tripping hazards anything more than 1/4 of an inch. So if a city has a 1/2 inch tripping hazard and some poor little lady goes down there and falls and breaks her hip, the city's going to be liable. And so we're trying to create an efficient and fast and quick way to find those hazards. We've even created sidewalk access information that could go on a corner, which might be important like in San Francisco where there's a really steep hill or something. And so that's what we've been doing with sidewalks. And then we decided that fitness equipment isn't very accessible. So we decided to create some universal design standards for fitness equipment. So this is my friend Mike. He's trying to sit on a really tiny, almost like a bicycle seat on a bench press, and he's paralyzed from the waist down. And he can't keep his legs on there because they're twisting all over the place. The treadmills have to have a lower step height. If somebody can't step up 10 inches, sometimes you can't get onto a treadmill. So the idea is that the step height should be down 7 inches or less to be able to get on the treadmill. The handrails on the treadmill, you should be able to get your hand around it to grip. You can see the one on the right, you can't even get your fingers all the way around that to be able to hold on to that treadmill. The pins for adjusting the weight shouldn't be black. They should be a contrasting color so somebody with a visual impairment can actually see the weight pin. The pin shouldn't require hand function. You should be able, quad with no hand function should be able to grab that T-shaped pin and pull it out. For somebody that's visually impaired, you think, oh, this screen might work pretty well, except if you are colorblind and you look at this in black and white, you can't see hardly anything on this panel because the contrast, the light to dark contrast on that panel isn't good enough. This is a different panel. It has much better light to dark contrast. So looking at the light to dark contrast ensures that people that are colorblind can also see the signage. We've also been working on some standards for people with cognitive impairments so that if somebody needs a product that's simpler, we want to be able to rate consumer products for their usability. So like a phone, you know, many of you might have an iPhone where you've got a touch screen and lots of layers that you go into to do things. But an older person might want a jitterbug. You know, with a phone, you open it up and you push the button and it calls Aunt Betty Lou. So we're trying to rate everything from fire extinguishers to microwaves, toaster ovens, common household appliances for their usability from a cognitive point of view to help people choose simpler products that need things that are simpler to use, because not everyone wants a microprocessor controlled toaster oven that you've got to punch in a whole bunch of stuff to run your microwave or whatever to make it work. Another thing that I like to work on is when the ADA was passed, the outdoor recreation areas all needed to be made accessible, and I got to participate in the Outdoor Recreation Advisory Committee for the Access Board to write the guidelines for accessibility for outdoor recreation. So we worked on amusement park accessibility guidelines, and so I'm still working constantly on helping the amusement park companies make their new rides accessible for people with mobility impairments. So I regularly go and visit Universal Studios when they're designing their new rides to figure out how we're either going to get a wheelchair on and off the ride. In this case, this ride was designed to allow a wheelchair user to roll onto the ride, but in other cases, the ride is designed to transfer. This is Spider-Man, so the whole body comes up off of Spider-Man, so there's no doorway to go through because the whole wall of the vehicle disappears to make it easier to transfer into the ride vehicle, and then the ride vehicle comes back down once you get in the ride. This ride vehicle has part of the side of it folds away so that you can transfer into the ride vehicle, and you see the part she's got her hand on there, you transfer onto that and then down into the ride. So it's like a transfer tier. You transfer down 6 inches and then down another 6 inches into the ride. This was Jurassic Park. It's a water ride, so they're really low and it's an old ride. So we had to design a way to get into it. So we did a plywood mock-up with a 2-tiered transfer mock-up, so you transfer down 7 inches and down another 7 inches and then down another 7 inches into the ride to get into it. So this is what the final version made. They just slip it onto the side of the boat and you transfer from your wheelchair onto the first padded surface, the next padded surface, and then down into the ride vehicle. So coming back out, you transfer up and then back into the wheelchair. So when there's existing things out there, we have to get creative with things like this on the existing rides, and then the new rides we try to design it as level as possible. Sometimes there's a level transfer bench to get into it. Has anybody been down to Orlando to ride the rocket coaster? So this is the first vertical coaster in the world. It goes straight up and then releases you, and the only restraint in the entire coaster is just one hydraulic thing that comes over your lap. And so it made it very, very difficult to transfer into the ride. So usually I'm visiting during the concept stage. This ride vehicle sitting in a warehouse, and I'm sitting in the ride vehicle, and that big black thing on the left there is between me and my wheelchair. And I'm trying to figure out how am I going to get out of this ride vehicle. And so on the right there, you can see we mocked up a couple plastic 5-gallon buckets, piece of wood, and my wheelchair cushion. And I'm like, well, if only my wheelchair cushion could somehow sit here on this diving board, I could get out of this ride. And the solution ended up being a transfer device that basically sat me on a diving board out in the front of this thing. So I would transfer onto this device, then they would plug it into the ride, and then I would transfer into the ride vehicle seat, and then the ride vehicle takes off. Because they usually have about 40 seconds to get in and out of the rides, because if you stop the ride, then the next car stops, and the next car stops, and then the next thing you know, there's people upside down stopped on the track somewhere out in the amusement park. So you have to make sure you can get in and out. So the final frontier problem that I just started working on about 1.5 years, 2 years ago is air travel. This is one of the most complicated problems I've ever worked on. One of the first really major problems is that the jetways are really steep going down to the plane. And in fact, they can be 6 to 10 degrees. So this is what that jetway looks from the side. So down at the bottom, when you get down to the bottom there, you got to turn on this cross slope and go over into the aircraft. We can't get into the aircraft in your wheelchair because they're skinny. So they put you in a boarding chair. Well, turns out that 12% of everybody that's flown in a wheelchair has fallen over in one of these boarding chairs in the jetway. 12%. How would you like to go do something? No, there's a 12% chance you're going to get dumped on the ground. 7% of everybody has actually fallen out of the boarding chairs. So the solution is to create a level area at the bottom of the jetway. So that's that one problem. The next problem are the boarding devices. This is what a typical boarding chair looks like. Pretty much kind of like a dolly, right? That you'd put a beer keg on or something and roll it around. Only they put people on these things and they strap them in and they wheel it down the aisle of the aircraft to get back to your seat. They're so narrow, and that's why they fall over. So we tested 20 subjects in our lab, having everybody try these boarding chairs out, giving us their opinions on them and what they liked and didn't like. This fellow says he'll never fly again because he's been dropped twice. He doesn't want to risk it again. We had a hard time getting him on the board chair. So better design solutions need to happen for boarding chairs. So if any of you are looking at working on a really challenging design problem, maybe in your master's program or something, if you want to work on a better boarding chair, I'll give you the design specifications of what it needs to be. The next thing is the transferring in and out of the boarding chair and into the airplane seat is really dangerous. So here I am, I'm in that jetway and it's tilting 7 degrees to the side. So I'm sort of leaning, trying to get onto this boarding chair, and I'm trying to help fold my wheelchair while I'm sitting onto this boarding chair, sort of half strapped in. So for my own personal solution, I designed extra wheels on the back of my wheelchair so that I can become my own boarding chair. So these are the little wheelchair wheels that are underneath my chair. So I pull my big wheels off, and now I can go down the aisle of the wheelchair by myself. Thank you very much. So I pull off my wheels in the jetway, one wheel, second wheel, pull myself over to the plane, and transfer in. Now there's another technology that's being worked on. We've designed a track so we can open the overheads, put a track up there, and then use a little battery-powered lift to lift the person and set them in the aircraft seat. And there's a company that actually makes a lift that'll fit down the aisle of the aircraft. It's called the Eagle. And this lift will actually lengthen and roll sideways over the aisle seat so that they can lift somebody out of their wheelchair in the jetway and then roll it into the plane and then set them over their seat and lower them into the seat. So that's a pretty cool device. They cost $20,000, and hopefully the other airlines will start buying them because they're paying for back injuries and injured passengers right now. So the next hazard is that airplane seats and the boarding chairs are not particularly comfortable. This is me sitting on a boarding chair. I'm sitting on my two ischial tuberosities and my tailbone, and those are the sitting pressures. I don't want to sit there for more than like 60 seconds, if at all. This is the pressure in my normal wheelchair cushion that I'm sitting on. That's the pressure sitting in an airline seat. Airline seats are not designed for comfort. They're designed to pass a crash test. Most of you probably noticed that if you've flown somewhere. They're not really soft or comfortable. So my solution is I put my wheelchair cushion on the seat, but looks what happens. My legs are dangling off the seat. My feet aren't even on the floor. So my legs are going to swell because all the pressure's behind my knee, and the headrest is pushing my shoulders forward, so it's very uncomfortable. So I use my backpack as a foot support. I put a lumbar support in my back. I have a spine support and a neck pillow because I don't have a headrest, I'm sitting too high, and a pad on the armrest. So with all that stuff that I pull out of my backpack and blow up and inflate and everything, now I can sit comfortably in the seat. Kind of complicated to travel. The next complicated issue is that the bathrooms are not accessible on the aircraft. If you've been noticing they're getting smaller and smaller, well, not just for somebody in a wheelchair, but what about somebody that needs a caregiver? Or what about somebody that's really tall? So we did some research and figured out that lots of people, 14 out of 15 people, knew somebody that needed assistance in the bathroom to use an aircraft lavatory. And as a result, most people will only fly for 2 or 3 hours without changing planes because you can't get to the bathroom. So we figured out that basically to get the space that's needed, it's just one modular 3-seat section that needs to be removed to make that bigger bathroom. 3 seats, 2% of the cost of the aircraft. 14 out of 15 people we surveyed said they would pay that additional 2% to have an accessible bathroom. Then we went on to discover that for every 1.2 inches of legroom, you can either add or remove entire row of seats. 6 seats changes the spacing between all the seats in the aircraft 1.2 inches. So you wonder why the pitch space is getting shorter and shorter and shorter in front of your knees. It's because Every 1.2 inches they decrease every seat on the aircraft, lets them put it in a whole nother 6 seats. And so that's what's happening in the airline industry, and so that's why they charge you for a little bit more legroom. But 50% of the people we surveyed said they would pay up to 4%. 4% per 2 inches, for 1.2 inches, so 8% would give you another 2.4 inches. So that's that problem, and then the last problem is that a lot of wheelchairs get damaged. So powered wheelchairs currently get lifted up off the ground by the ground handlers, put onto the baggage belt, rolled up the baggage belt, and usually it's not high enough to get the wheelchair into the aircraft, so they tip it onto its side. And you see the joystick hanging up in the air just below the engine there? That's the part that's most vulnerable to getting destroyed, that little plastic shell with the joystick in there. Plus the wheelchair's lying on its side. It was never designed to be transported that way. So these are the kinds of things that happen. The wheels break, the armrests get broken off, the connectors get broken, the fenders get broken, the entire wheel got broken off this powered chair. And that's what's happening. Every airline right now is paying millions of dollars every year because they are destroying people's powered wheelchairs. So we are creating a standard to design powered wheelchairs for travel. First thing is they'll have a travel card that shows how to prepare it for travel. The backrest folds down, certain things unplug, there's hook points for securing it, there's places to properly lift it. So first of all, they have to be able to disengage the motors so you can push it. Then they have to be able to know how much it weighs to figure out how many people to lift it or what equipment to use. There have to be some little stickers to show where it's safe to pick up. There has to be a power switch to disconnect the battery so the thing doesn't catch on fire if something starts working on the wheelchair. We've designed a whole set of symbols to try and mark the chair, and we're developing procedures for handling the chair. The chair has to have securement points for tying it down. That already exists for transporting wheelchairs on buses, so the chair needs to have that option. Then it will have little symbols where you can remove all the parts that can just be removed. The leg rest, the armrest, the joystick. All those parts need to just come off and go in a bag and go in the overhead container so they don't go down with the wheelchair and get broken. Then the joystick has to disconnect so that doesn't get destroyed. And then it has to get shorter. So this chair, the back pulls off, the leg rests come off, seat back folds forward, and it can be driven up into a car. So this wheelchair will fit into an aircraft without having to be tipped on its side. So hopefully when we finish the standard, we've pre-balloted the document. We're having a meeting in a couple weeks to clean up the edits, and we're going to send it out for full ballot. And then hopefully by the summer, the manufacturers could also start building chairs that meet these guidelines. In the meantime, we suggest people go to Walmart and buy plastic containers and try to cover the joystick, put it inside a plastic box of some kind to try to prevent damage to it. On my manual wheelchair, I fold it and I strap it shut to make it work with a little elastic buckle. So the Paralyzed Veterans of America has funded us for that project. And it's all about assistive technologies, about being able to get out and continue to do things wherever you want to do it, if it's a ferry boat, a tour boat under the Golden Gate Bridge. And I thank you all for coming today very much. Thank you. I think there's 1 minute. I got room for 1 or 2 questions if anybody has a specific question.
So, Peter, thank you so much for your presentation. But I wanted to ask you, you mentioned that several of your designs are now being sold by other people.
And people are leaving. If you want a card, I have some business cards, and my daughter has some business cards back there. If you want to talk after this is over, or go to dinner with us, or have us come back in the morning, let me know. Thank you. So, David, go ahead.
Well, we should first thank Peter before people head out. So, thank you. Secondly, you mentioned that some of your designs are being sold by other people. What was your decision process in having other people make them rather than yourself?
So I'm a person that likes to keep developing new things, so I didn't particularly want to be trying to manufacture and market anything that I'd have to have a whole company revolved around their product. So like the Spinergy wheelchair company makes the wheels already for wheelchairs. So it was just a natural fit that they would make the flex rims because they're already making wheels for wheelchairs. The Adaptive Paddle Sports company was already making all kinds of adaptive paddle sports, so it made sense that they would make the seat. And because it's a high-risk product for recreation, we don't even want a license fee from them because we don't want to be liable for the design. They're manufacturing it, they're distributing it, they're doing the production engineering. So high-risk products like the monoski, cross-country ski, we put all those technologies in the public domain so that people can make them in their little garage companies without insurance, which is what they do, and we don't want to assume liability for those designs. So if we see that it has a potential, we'll try to, get a patent, but we've never actually even ever recuperated the cost of a patent on our wheels even. So it's a very difficult thing to try to market in the rehab. If you're very lucky if you can get the product out there just to be available for people. So, yeah.
We're at the end of our time for the class, so I want to thank Peter again. And if you have any questions, we have a few minutes before we need to head out to dinner. And while I reset the room, thank you again. And I'll be sending you information about the field trip to the Magical Ridge Playground Thursday. Thanks.
Thanks for